Hello, I'm Mason Glover, Programming Manager for Ridgecrest Robotics, and I have 3 minutes to tell you about our robot's program for incision decision. Our robot is designed to complete several tasks, including cardiac ablation, artificial heart valve installation, arterial plaque removal, arterial stent insertion, coronary artery bypass, and the autonomous brain biopsy. We have designed our program using Simulink. However, these tasks require a program more complex than traditional methods in Simulink allow, requiring the use of a state flow. Now I'm going to walk you through how our program works. The most fundamental portion of our robot's code is the drive function. We use tank steering, which requires 2 joysticks with vertical motion and 2 motors as shown here. The necessary interactions for this function take place within the state flow discussed later. Our robot has a lift and a linear expansion system, each using 2 bumpers on the controller and a motor as shown here. The necessary interactions for these functions take place within the state flow discussed later. Our robot has 2 vane vices for grabbing the LEG vanes. These vices each use a servo and 2 buttons as shown here. 2 buttons are used for each vice due to variances in driver preference. Each set of buttons is paired using an OR block, and a latch is used so the input value is toggled with a single press. The remaining interactions necessary for this function take place within the state flow. Each of our robot's vices are mounted on a flap so they can be rotated 90 degrees. Each flap is rotated by a servo, and both flaps are controlled by a single button. A latch is used so that the button's value is toggled with a single press. The remaining necessary interactions for these functions take place within the state flow discussed later. The most complex part of the program is the autonomous portion. The autonomous program uses 2 buttons labeled auto and abort, 3 digital inputs for IR sensors, and 2 variables for speed to allow the values to be easily changed in debugging. The variables autospeed norm and autospeed turn are each declared and assigned a value here, and connected to the state flow here. Within the state flow, the program begins at the blue circle. The arrow will direct the program to the primary state. These first 6 equations simply set each output to the appropriate input. These last 2 equations will cause each output to be positive 127 when the upper bumper is pressed, negative 127 when the lower bumper is pressed, and 0 when both or neither are pressed. When both the auto and abort buttons are pressed, the program will move to the auto start state. In this state, the output to each drive motor is set to the autospeed norm variable discussed earlier. When 5 seconds have elapsed, the program will move into the auto state, where each drive motor will continue to be assigned the autospeed norm variable until the left or right IR sensor reads 1. Then the program will move into the auto left or auto right state respectively. In the auto left state, the right motor output will be assigned the autospeed turn value, while the left motor output will continue to be assigned the autospeed norm value. The inverse is true for the auto right state. All autonomous related states will return to the primary state when the abort button is pressed. All states except for the auto start state will return to the primary state when all 3 IR sensors input a value of 0.